Hey guys, we are back. Let me just set everything up. So today we'll be making, first we'll be making sure the entity component system we made works. I plan on using the L texture class as an example and making that its own component called just like texture component. And then I also plan to like make a system for it, like a rendering system, which renders all the textures pretty much. Now I think there's two ways to go about it because I have used the ECS before, but in that one I did all like the logic. So I made a bunch the components for classes and like all the logic like like load file and stuff was all in those classes. And then the system would just call all the it basically just be like a for loop and it'll just call every entity that has that component and run certain functions of it. But if we go back to the one guy's example, if I just search up like entity, where is it? Not simply learn. This guy's. If we go to his source code, I think his components are just structures, and then the system is like what does all the logic. So let's look at that real quick. So the camera is pretty complicated. Let's see. Well, he's doing like matrix transforms. Okay, let's not do that. Maybe it's too gravity. Just the force, like just some stuff. Player doesn't even have anything. Renderable has a color. Rigid body. So yeah, that's like pretty much all his stuff. It's just and then all like so and then his systems do all the like camera control system. No, I think this is like the intended way to do the ECS, and I think the way I did it before was just kind of like whatever. I guess it's a design decision, but I'm gonna be trying to do it this way because I was following this guy's tutorial, and it does make sense. Like the system's what does everything, and then the components are just data. So, and the entities hold the components. That's the plan. So first let's get some 10-hour video game music going on. So where is this? Documents, code, SDL3, and then nasty Tetris. So if we do get status, let's see, we did, yeah, so the two goals we want, we're almost done those goals with the getting separate files and the separate files and the what's it called? ECS. One thing I'm curious. Yeah, its components are just header files. But its systems are HPPUs. So I might structure my folder like how he did, pretty much. So I might rename the classes folder to like core or something. And he split all his stuff into multiple files. I just have one file called ECS. I think that's good enough. Although maybe I will split it all. I don't see a point in it though, too much. Actually, I do see a point in it. Maybe for another project, I'll split it up. But for now, it's whatever. As long as it works. So now we're here. Let's get the TMUX session going. If you guys don't know what TMUX is, it's just like, I think it's a terminal multiplexer. The only reason I like it is I can create new windows like this and just have one of them running Neoman. Dog's going crazy. I'll mute my mic for a minute. Alright guys, I'm back. Or my mic's back. So yeah, right now I'm gonna create the L texture, my own version of it called texture component. And can you do it like this? I see, yeah. I should set up like keybinds to like open Brave on my screen, almost like I have with like Tmux. Cause I go to search stuff up quickly, and I do like split screen a little bit, but right now I'm gonna use it to split with the other texture so I can create it. Although it looks like I already started here. I think I was trying last stream, but first let's include the entity components system. Do we need to actually? So like right here, it would be nice if we just open up the browser. Let's see. Let's look at his components. Oh, that's not what I meant to do. Let's go to components to transform. No, so he doesn't even declare them as a component. He probably does it either, probably in the main CPP. Yeah, that's right. It registers all the components right off the bat. Yeah, I think that maybe that'll be like my next thing I do, like setting up hotkeys for my development environment. All right, let's include the ECS. Oh no, we don't need to include it. That's only for the main. We're gonna need those though. So let's just uncomment all of this. And let's work from there. So I'm gonna have struct, call it texture component. Did I spell it right? Yeah. And like I said, we're gonna make it so the system does all the logic, and this just basically defines the values. We're also gonna make a render component. No. The SDL render is something else. This draws the texture. It says the color modulation. Hold up, let me get message. Alright, let's get the texture though. So we need the SDL underscore texture. And how did he name it? Did he? Because with structs, you don't really need to do member. Oh, you just called it. Whatever. We'll leave the comment too. Contains texture data. Width. Okay, what else do we need? I feel like maybe we should add some of these stuff, like blending mode. I was gonna need, okay, yeah, there's definitely gonna be more stuff we need with the stuff if the things, the systems and everything. So like we're gonna need like we're gonna need like the string path. I wonder if we can do that K original size stuff. Probably. I'm not really sure what that is. And then maybe like create some like, let's see what else. Like this color modulation stuff. That might be useful like if No, that will be useful. Like when all the blocks come together, the I was gonna say when all the blocks come together, they need to have different colors. Or maybe we could just replace it with like an image or something. We can definitely give it default values though. So like we could definitely go like uint 8 red equals 255. Actually, where it even is let's see, do we use that color anywhere? Let's look at our example we made. The color alpha button. Here we go. Shit, I gotta use my color. Maybe we don't need that. Honestly, if we need it, we can always add it later. So yeah, we won't use it. What's it called? Height, width. That's like where to draw the texture. That will probably be better as like a vector 2 or something for position. Sorry. Oh, there goes the dogs. Okay, yeah, so they just have like a position rotation scale. So I think I'll do something similar to that. But not in the texture. I think the texture, this is all we really need. And maybe that color modulation stuff. Yeah, okay, we won't use the color modulation yet. We don't need to complicate things. Alright, so that's good. And then what is his... Okay, if we're doing it this way, we're also going to need transform. So we use transform component dot h. Okay, and if we're doing that, we're also gonna need like a vector. So let's pick the. We'll create a vector2 dot h and probably a vector2 dot cp. Okay. So I'm gonna make a class vector2. Nah, I always like starting with the private. So we're gonna need sync float xy. What else does a vector need? Oh, it has a direction too. Vectors always have a direction. So then we're gonna float should I call it direction? Or should I call it degrees? Let's see. We're using this guy's stuff a lot. It would be in his like math. Let's see, vec2. Oh, he just has it all public. You know, that kind of makes sense. And yeah, he just says xy. Okay. So we'll do something similar. Instead of using this private or whatever. Because then you can just do dot x, which is kind of nice. So let's make this vector2. I'm just getting messages. No, I think because it's core, I don't think I should use thing. Now I know there's like a special way you do it in C++ for like class definitions. I'm gonna open up my Ubisoft one. Oh no, it's literally just that, yeah. And by doing it that way, and then yeah, using these constant stuff is like how you do it. And he's doing like what is that? Operator plus? Oh yeah. So you can just like add vectors. Vector 2. And do. I already forget. Okay, that's the equal. I see. I think I just say 0f. The y as 0f. And then underneath, you just go like that. Yeah. Why? Okay. Okay. Sorry, too many things happening. So we also have vector 2 where you can define this. So float x, float y. Now I forget. Can you do it the same? Yeah, you can. Okay, nice. Makes it easier. It's not like I haven't coded in C++ in a while. It's more like I haven't coded much this summer because I was in summer school. So forgetting a lot of this stuff. Also, there's a lot of, I mean, like a bunch of important messages and stuff. It's just, yeah. It's hard to just pay attention. Now this dog's freaking out. I'm babysitting a dog right now. Oh man. Okay, well, either way. So we had that. We have the default one. I think that's all we need to define it. And then, what you call it? It's nice to have like, there's some vector stuff that's nice to have. Let me open up my GitHub. So we'll go open up a new repositories. Let's look at my, where is it? This one here, because I did make a more in depth where is it? Oh, probably like under like graphics maybe. Collision. Where the hell is it? Physics. Nope, not particle. Oh, here we go. So this is for vector 3 though. For some, yeah, so like an operator overload would be nice, so you can just add vectors. Although I might just make it like an add, like dot add, instead of doing these operator overloads, because those can get kind of annoying. Yeah, I think I'll do that. I think like it's a quality of life, but like generally you should stick with like operator overloads are kind of hard to kind of know. I mean, they're kind of standard too. It might make the also might make some of the like math a lot easier. Okay, I'll add the operator overloads. I'm gonna put this on my other screen so I can just refer to some stuff I need. So I like to go like this. Constructors. Let's call these operator overloads. I think that's what they're called. So we're gonna have vector 2 because it's gonna return itself, right? And you do operator and then plus. Let's do a const. So this is like some optimization stuff. The reason you do this is if you have a big let's say you have a big like object you want to put in. So what C++ actually does as parameters is it makes a copy of it. Now if you have an object with like 1,000 members, that's a lot of data it has to copy, and it can be way too much. So a nice thing about C++ is that you can just copy the pointer to that value, and you put it as const because you don't want to change the pointer value. I think that's why, or you don't want to change the actual value. One of those two. But instead, you're just copying a pointer, which is a lot less memory. It's just it's just a bunch of numbers and stuff, right? So I think that's what makes C++ one of the preferred languages to use a lot of the times for when you need a lot of performance. So yeah, we're just gonna construct it. We're gonna do x plus b dot x, and then it's gonna be y plus b dot y. All right. Let's now do let's do a plus equals. Which is slightly different because is it different? Hold up, let me think about this. When would it be better? I don't think we need that yet. If we need it, well, I'll add it. Should do minus operator minus same stuff. I think the plus equals would be good for like scalar instead of vector whatever, but either way, whatever. Cons vector 2 x minus b dot x, y minus b dot y. Okay, let's also do multiply. So Usually for multiply. Well, we can just overload it. Yes. Turns up up in this. Oh wait, is it like when you multiply two vectors, you get a scalar from it, or something like that? No, there's usually like a resulting vector, right? No, yeah. The cross product. Oh, the scalar product? Okay, wait, hold up. What is this again? Difference between cross product and dot product. That's what I'm looking at, by the way. So dot product is it the angle between? Let's watch this Khan Academy video real quick.
Let's do a little compare and contrast between the dot product and the cross product. So let me just make two vectors, just visually draw them, and maybe if we have time, we'll actually figure out. I'll always do the acute angle. Okay, let's call the first one, let me just label them. Take forever if I keep switching number. And that is the dot product, because you end up dot A. So what does A dot B? That, well, first of all, that's the exact same thing as B dot A. Order does not matter when you take the dot product, because you end up with just a number. And that is equal to the magnitude of A times the magnitude of B times cosine of the angle between them. Fair enough. Let's look at the definition of the cross product. What is
Why is the quality so bad? Oh, this is the highest quality.
Cross B? Well, first of all, that does not equal B cross A. It actually equals the opposite direction, or you could view it as the negative of B cross A, because the vector that you end up with ends up flipped, whichever order you do it. Like the dot,
this is cool.
the
like
sign of the angle between them, and this is where it really diverges, right? This, when we took the dot product, we just ended up with a number. This is just a number. There's no direction here. This is just a scalar quantity. But the cross product, we take the magnitude of A times the magnitude of B times the sign of the angle between them, and that provides the magnitude, but it also has a direction, and that direction is provided by this normal vector, which it's a unit vector. The unit vector gets that little hat on it. It's a unit vector, and what direction is it? Well, that's defined by the right-hand rule. This is a vector. It's perpendicular, so perpendicular to both A and B, the way I drew it. In order for it to pop into the screen, because that is these two it is, because both of these vectors are perpendicular to A and B. Well, that's where you take your right hand and you use the right-hand rule. So you take your index finger in the direction of A, your middle finger in the direction of B, and then your thumb points in the direction of N. So let's do that. I'm looking at my hand, and it looks like It's actually not an easy thing to do with your right hand, but your right hand's going to look something like this.
Okay, that's cool.
A, my middle bend of hand. If you drew it correctly, where it would actually, you would see your hand, your pinky would be like that. You wouldn't need, this end just means it has a close. They in fact watch it because I think
I want to know what actually
cosine of
dot
this.
vector is.
B cosine of B. No, theta is if you drop a line perpendicular to A, this is right angle. B cosine theta, adjacent over B. So we would have same direction, the dot product. So how? Let's take the pieces that go in the same direction and multiply them. So how much do they move together, or do they point to get together? Or you could view it the other way. You could view the dot product as, and I did this in the dot product video, you could view it as A cosine of theta B, right? Because it doesn't matter. These are all scalar quantities, so it doesn't matter what order you take the multiplication in. And A cosine theta is the same thing. It's the magnitude of the A vector that's going in the same direction as B, or the projection of A onto B. So this vector right here is A cosine theta, the magnitude of A cosine theta. And they're actually the same number. If you take how much of B goes in the direction of A and multiply that with the magnitude of A, that gives you the same number as how much of A goes in the direction of B, and then and then multiply the two magnitudes. Now, what is AB sine theta? AB sine theta.
Okay, let's see what it means. I don't think that. It tells you the amount of one vector goes in the direction of the other. If you pull the box 10 meters and incline angle, there's a horizontal component. Okay, maybe this would be useful for 3D. Even the cross product I don't see being too useful. Like, I don't think we're going to be using it too much, so I won't even make it here. I do think like scalar product and stuff, like where you just multiply all the values, will be useful. So I'll create that. But let's look at the operators again. Yeah, I'll make the scalar. So I'm gonna do. It's gonna return another vector too. We're gonna need a const. So scalar. Now I'm not putting ampersand here because this is it's not an object. I don't think you put for objects. Could be wrong. Either way, it's fine. Like the memory hit. Like I'm not too worried about this project, especially like with thing. This is 2D, so we don't need Z. And I don't think you would ever. Maybe you would divide. I'll put scalar. Or yeah, scalar multiplication. Scalar division. I guess maybe if you want to like half the distance or something, it might come in useful. I can see it. So, but like I said, we don't want to scope creep too much with this. Scope creep's the killer of all game depths. Not, why am I doing multiplication? It's division. Although I'm pretty sure floating point division is not the best. Like not the most accurate. Forget a lot of these stuff. Oh, the plus equals would come in useful. Yeah, like I said, if I need it, I'll make it. So I just start making real stuff. So let's make like a 0, because that's actually useful. No Z. This is 2D. I remember using invert actually. Maybe with collisions. Also, invert would be useful for things like flipping the shape. Although, we'll get more into that. Call these useful methods. Getting the magnitude of the vector would be nice too. So we're gonna get magnitude. I think we'll get so you spell magnitude. And so the magnitude of vector is just the y, square root of the y squared plus x squared, right? Let me search it up to get magnitude. Square root of x squared plus y squared. Plus, well, they do z squared, but doesn't matter. So let's do a square root. Yeah, let's probably include the math standard math library. SPB standard square root. Okay, so we need to define in this. So we can do standard square root f. And then we put in I mean x squared is just this. So x squared plus y squared. Okay, another a get direction will also be useful. So we'll make that. Would this square magnitude be useful? No idea, so I won't use it yet. I feel like I remember doing something like that. Let's do float get direction. Get the dogs are going crazy. Yeah, let's. Well, we can get the direction vector. No, direction vector is if you have two vectors and you wanna, or 2 points and you wanna cut the vector towards it. Oh, almost forgot normalize. Normalizing is useful. So you need to get the length of, no, the magnitude first, which is, I think you can just get magnitude because it was within the class itself. Put this dot magnitude. I don't know if you can actually see this. Yeah, no. We just go like that. And then you do if magnitude. Okay, it will never be negative, so if it's greater than 0, then we need to, how do we do this? Switch up. How to normalize a vector. We normalize that we actually calculate. So the vector divided by the magnitude. Oh, useful. We created that. So okay, we actually need this in this case. I think it's like, let me just search it up. How to reference, how to use this in it's like geeks for geeks. This pointer points to instance. Okay, this is what I'm talking about. Okay, so it's a pointer. Now, if I recall, then we just divide both x and y by the scalar, right? By the magnitude. No, you divide the actual vector by the magnitude. So you want to have length 1. So you divide the vector by, yeah. So just divide, which we did. To make a division 1? Well, I gave it the wrong symbol. Because the scalar now is the thing. Okay, so this is a case where the division equals would be nice. But let's. So I think you just do this. This divided by. Can't do that though. Okay, it's equal to the square root of was there just not like a clear like answer? Normalize vector formula. Oh, wait, what am I? Okay, this is easier than I thought. I'm overcomplicating again. So we do this dot x is equal to, well, not dot because it's a pointer, so we do x divided by magnitude. That's what we do. All right. Now the only one I see useful is getting the angle and getting the distance between two vectors. So let's do the and getting a vector direction vector to like another one. So let's do the get angle radians first. Let's do float. Okay, I think I don't know. To get the angle of a vector. I mean, I could do this myself, actually figure it out. Because, for like dot product, you need the angle between. So you get cos theta. Oh, we need like a defined dot product then. Let me search it before. How to find. Whole article. Where's the formula? Okay. Angles are tan of y divided by x. So how do we do arctan standard CPB? Let's see. Okay, so we're gonna return standard A10 F, and we're gonna need y divided by x. But that returns a float, yes. What else do we need? I think that's good. I think this is good enough. I don't think we need anything else. I really can't think. We probably won't even end up using all of these. Okay, so let's go back to the texture component. No, we're going to transform component. Now we're going to need to include it. So core, and then what is there? Vector 2. might switch the names, transform component just to transform. Another thing, like kind of like getting stuck on the not necessary stuff. So we're gonna need a vector to. So transform usually has its position. Vector to usually has a rotation. And it usually has a scale. Going based off what Unity has and what I remember. Alright, now let's create our render system because we need to render stuff. This is all just a test. Well, test and like this will be useful. Make sure the ECS works. Systems. Call this render system. And I think this one I'll create the CBP file for as well. So now we're going to need to include the ECS.h. Because we want to make this I kind of forget. Do we make it a subclass? Because we don't do it for components, right? So maybe. Let me look at the tutorial. So you make it a component of system. So let's look at system. Okay, yeah, I remember this. And then, okay, yeah. You gave a little example. So you'd make it where's the example? Maybe I didn't write that example. No, I didn't. Kind of remember. I think you make it a because system just has the entities, a set of it. This is so what functions will I need? Let's look at the actual like how do we render in program? Like what's all the steps? Let's see, do we need to do anything here? Okay. Yeah, we definitely need to initialize some stuff. So like this render vsync. This create window with renderer, that's important. Let's do void. We'll do capital so we can distinguish it. Yeah, but now we're gonna initialize. In the initialize, we can also do all these load texture stuff. Then we also need to clean up. No, cleanup's for like global stuff. We won't be having global things anymore. Is there anything else we need? Alright, I'm back. So I'm creating the render system right now. I'm just planning some stuff out. Like, I think we'll need the screen height and stuff. And I'll probably define that in the init. Let me just check real quickly. I almost think that, like, loading up the window shouldn't be part of the render system. And it should be its own thing. Because it looks like for the window, it's just... Yeah, I think I'm gonna... But I'm definitely gonna need those render stuff. Because, yeah, render present updates the screen. Set the background color, yeah. So, like, I think all that will be handled by the renderer, not the window stuff. So I think this is pretty solid. That's what we really need to do. We need an update and an init. So then let's start actually making the render, like defining it. Did it? So we're gonna call render system.cpp. Hashtag include. So all we probably need. And every time we need to include something else, we'll just add it to the thing. So let's. So we don't even need a really constructor or anything. Because I think we construct it using the like coordinator. Yeah, because we have all these like add components, create components, system, register system right here. This is a template. So we registered. Oh no, we create like an instance of the system, and then we what do we do? So we'll have the coordinator, and then we'll register the system. Oh no, we don't do anything, but because it's I kind of remember now. You gotta do like these, define like the type it is. So we'll do the camera control system because it's all inherited from the system class. Yes, and so we actually don't need a constructor because how would it work actually? Look at the example. It doesn't look like they set the stuff anywhere. Oh wait, no, we wouldn't do it in the init. We would set the signature like in the main function, just real quick. Yeah. Okay. So let's start defining stuff. Render system. Init. So what do we need to initialize? Now this is initialized with audio. We don't need a global render anymore because they'll all be rendered for the same thing. Where is it? We need this. So we're gonna have m render is equal to null pointer. Let's go from the top. Maybe FPS if we need the VSync. These are all the definitions. That's it for init. Okay, load media. This is also stuff we need to do. So we pretty much need to loop through the entities with um, components of textures, which I think the system, when we define it, should have, like, we add it in the main. Let me open up the thing. I'm gonna just copy one of these and just paste it here, just so I could reference it. Let's go to the ECS. Like when we I think everything pretty much happens in the coordinator. So let's look. Yeah, so when we do like add component, it sets the signature. Oh, we're adding the component to the entity, and then it updates all the system stuff. What does register system actually do? Let's see. It takes the type name. Okay, yeah. Assertion. So it makes a pointer to it. And it adds it to the system's map, I think, right? Yes. So I think we would register the system, and then from there we would add all this stuff. So in the init we Okay, so I think this is what we do. So I think we go. So we need to initialize all the stuff. Initializing textures. Because we know that the render system is going to need, like, we'll define it in a way where it has to have textures and transform. Yeah, so we'll initialize all textures. So for because we don't know what the entity is gonna be in M entities. We're going to get a texture and let's do transform. We're gonna need an instance of our coordinator, which is, it should be a global. That should be like probably our only global variable. So how do we get a? I'm gonna search it. How do we have a global? Cross files. Let's see this. That's the best. So common.h. So he sets global there. So I just have to include it. Now, the question is, where do I define this coordinator? Like, where should I? There's no like main.h, so maybe in this render one. I think render is a good place to define the coordinator. So let's do that. Let's up here. Okay, we don't need to. worry about those errors just yet. So I just have that there. So let's make the coordinator. Let's call it coordinator. Because now we can do G coordinator. Like we could even like create. I was thinking of creating the camera here too. Although we should probably make the entity for that first. Either way, let's see it. So we have G coordinator. What am I trying to do here? Oh no, we're trying to get the component. Yeah, so we're gonna get components, and we need the type. So it's gonna be transform component, and then we need the entity, which is entity. Do we need to? Yes, we're going to include it. So we're gonna have and then what does it say? Oh, I don't need to worry about that. It's saying in the text. Even though it does find it. What do we even need to do with the transform? Why was I getting the transform? I think the transform would be more useful in the the transform would be more useful in the the update for any of these positions. So let's do texture. Okay, now we can do this. Like this, g.texture. So we'll do if texture dot texture component. Oh, that's kind of wait, texture dot texture. We'll do texture. No, I'm good. And it's a struct, so we can just get. Wait, but g.texture. G.texture is an L texture, right? Yeah, okay, so we're gonna need to go to. Alright, here's low profile. Okay. So actually what I'll do is we'll create a function. We'll call it bool. Load texture, we'll do render. I don't need that because it's a mem variable now. That's something we need to do. We need to initialize render here. Oh, which I did. Okay, now pointer. You know what? I probably don't even need this. Whoops. What was I doing? Oh, it's the low texture. So we have the render and then we need the string path. Oh, we'll also need the so we're going to do then we do texture dot did we make a destroy function? No. How to destroy it. Wait, what does destroy do? So it invokes the destructor of the object, which is particularly useful when dealing with. This is in it, so let me be called once. Honestly, I don't think I need to worry about this. What is it to do? If SDL underscore surface. I think we can pretty much copy. So we'll do. I said that we'll do. SDL texture. Okay, no, we should do. That was fine. We need to do. M texture is now transform component. I forget. I think it's just dot. That's nothing on it. No, it's just texture. Okay, it's not transform. What am I doing? It's texture. Oh. There we go. And then this is texture component dot width. This is texture component dot height. You don't even need the string because we already have path. Transform. Not transform. I like you doing texture. That's fine. Okay, and then we need to define this. So it's gonna be pool. What does this error say? I don't need to include these. So if now we just do if load texture it just puts an error message. Where is this? This is in load media. So I guess in init we'll call these textures. I'll make this a bool, so we can just do some error. So we already have it like that. Thing loaded. Okay, I don't think we need this anymore. I'm gonna say to do init camera here. Okay, now for the update, that's when we had to draw it all to the screen. So that all happens in the here. Do that. Screen width, screen height. Hold up, I'll be back. Alright, I'm back. I just grab something to eat. Okay. Oh, here's what I was gonna do. I was gonna do the camera. No, I think I might put the dimensions here for the camera. I guess a parameter. Actually, I think I'll just do it like hard coded in. Maybe not, because it might change. Like, I think I'll put it as a parameter. Or maybe I'll make like a camera class and then throw that camera in here. Like, just a structure. It doesn't need to even be a class. Because there's not really any... Or maybe class, because you can bound it or whatever. Okay, well, for now, we will just hard code it in. And also, we'll do like hard coding this. What is it? 1920 by 1080. So 1920. Or what's the other one? 1280 by 7. No, let's just do 1920. Go to definition. Let me actually search this up. I always just assume it's like an array or something. Let's do SDL underscore rect. Like, what even is it? It's a structure with X, Y width height. Too bad it doesn't show you any documentation, doesn't show any examples. I guess that's just how you, why he does it that way. I think that's how you define, like, I guess structures. I can do camera dot x. I actually said doing this, so we can just go. Oh. I want to get some vitamin C. Okay, I'm back. Okay, now let's do the update. So we can just copy this. And instead of G render, it's gonna be M. Okay, and then render stuff, and then update screen. I bet I can do this frame rate stuff here actually. So let's get the nanoseconds per. No, we don't need that. We need the M screen. FPS. It's gonna be. We're also gonna need cap timer. How's cap timer? No, it's up here. Oh, cap timer is an actual timer. Ooh, okay. Let's gotta move that to another class, man. Just getting this render thing working. I need to get like everything else working too. Okay, screw the frame rate for now. Is there anything else? Stop text to window. That's for the window. Okay, then here we'll do the frame rate. If time remaining in. Alright, this is where the real stuff comes in. So we do for auto. How do I do this again? For auto constant. And M entities. So we're gonna want we're gonna want the texture component and the transform. I feel like auto const is backwards. I think it should be const auto. Right? Either way, I don't think it matters too much. I'll just search it up. Yeah, I'm just gonna, for clarity's sake, change this. I think it should be constant and auto because it's a type. How did I do my infected 2 plus? Okay, yeah, I'm not. Gcoiner dot get component transform component. Okay, let's go to the, because it looks like we just use this dot render method that we made. So let's go to L texture. Where is the dot render? Okay. We're going to copy that. Okay, there's some stuff we don't need here, like this SDL render. We have the flow X and flow Y. We don't have the clip. Width and height we have. Degrees we have from the transform. Center. What do we even use center? I should probably go here. Yeah, okay, this is where all the real stuff is. Okay, now we'll do it. So DF, boom, we don't need that. We don't need that, we don't need that. We don't need that either. Degrees. Why did I make rotation a vector? Whatever, I won't worry about it yet. We're not rotating stuff yet. I want to make this capital. Yeah, so I need to get rid of all the default arguments. So where is it? That's low texture. Oh wait, what am I doing? It's was gonna say no way, I just deleted it. There we go. We're actually gonna change this definition, but we're gonna need the transform component. You're watching? What's up, Emily? I've been trying to get this one thing working for so long. It's not going too well. You can type in the chat, you know? You're my one and only viewer right now. Here, yeah. That's funny. How long's the delay? Is it like 15 seconds? Well, I'll see when you text me. Okay. So we're gonna make this transform component a position dot x. That's kind of a lot, right? That's okay. Transform component dot position dot y. The width comes from the texture component. So we're gonna texture component. Dot width. Whoops. I got 2 viewers though. Hey, I can see like what it says. Oh, it does. Yeah, 2 viewers. So this is the height. So I can just let's replace that with texture component dot height. Okay, let's see this. So we won't deal with the clip just yet. Resize this nude. Let's not do this. I don't think this is too necessary. His feeder, what are you talking about? Okay. Texture is actually just texture component dot texture. And then we don't need to worry about those other stuff. I don't really know what it does myself, so. Like you heard it go off, like I didn't even hear it. That's crazy. I need to find a way to like make the mic not pick up background noise. I thought it makes it kind of funny. You should have heard earlier, like Charlie was going crazy. I had to like mute for a bit. I'm writing all this code without testing any of it. Like usually it's fine with only a couple lines, but okay, I think the render is ready though. Oh no. No, I made the render function. So I need to actually call it. So I need to do render transform, and then we need to do texture. He leave no good luck. Okay. So now I think that we can actually then we can quit this side. Let's go to game CPP and let's do some stuff now. Okay. Let's go to global variables. Because now we need to create the coordinator. That's like the most important part. I guess they're just up here. I'll do it. We're gonna do hashtag include source slash core slash ECS. Okay, so we don't need this no more. Shouldn't need these, although let's see, let's just get rid of background texture because dot texture is a little different. Even the dot, I can't. Let's not even run the dot. We gotta like, because all these use the render function from the. I'm just gonna comment that out. You don't need buttons yet. Timer. Dot. Square. I'll show notes here. Square move. Because I already got rid of L texture. Which is pretty much the only thing I'm testing. Yeah, we'll move timer. Because timer will actually be good. We'll eventually need to do this rendered texture stuff for text. Yeah, let's just boom, fat comment. Okay. Now this, and then we still need to edit this video and that's the thing, it uses the G render. Cause yeah, we're gonna need the render. Maybe we should do this stuff in the renderer. Because we need to pass the M renderer in there. Or you know what? We can we can make like what is it? A constructor for the render system. We could do maybe we just do make the render global. No, I don't think we need to. It's just for like these two things. That's literally it. It's really annoying. Create window. Okay, yeah, so I think the plan is I think we could just create like a get renderer. No, but getters don't actually make a pointer. We make it like a static, so global member. Maybe we'll create the window in the renderer as well. Maybe we just combine them for now, the window and renderer. So where else do we use screen width and screen height? It's like what I need to change the screen with. Not for this project. I'm like just gonna. I gotta get used to just like fucking hard coding and then dealing with it later. So it just ends. Just return false. I need to say. Give me the window. Okay, that's all good. We do not need VSync. And I probably don't even need these houses. Okay, so let's get rid of. So I just want to get this working, and then. Okay, for the media part, we don't need to load these textures no more. Instead, what we should do is we should pass the render system in here. That might be. I'm gonna say call render system. I guess we're just moving the load media in it to one spot. Which should be fine because if we look at the. Let's make sure this is all good too. Still close. Maybe we should have an init for the system render and a load media. That might be best. Where else do we use G window? Is that it? Yeah, that's it. Actually, that shouldn't matter too much right now. I'll put those to do. Currently. Okay, let's go here. I need to clean up the texture somewhere. Does G or coordinator have something for closing everything? Destroy entity. Here's system. Now this guy used these, but we have actual pointers and everything. So we gotta close. We need to close. Access void. So let's go void render system close because we need to free up all the STL texture stuff. And there's some other pointers too. Like we need free M render, M window. But first let's get rid of all the textures. So for texture components equal to the G coordinator dot get component texture component entity. So we need to do texture dot destroy. So it just resets all its values. So do texture component. And we'll do it like this. We'll do not transform texture. So that's a null pointer. Okay, now we need to. Where is it? Okay, so now I can. Let me just check the main one or NF one more time. Sure doesn't use window anywhere. No, it doesn't. Nope. Okay. I think I got everything. For this, I'm gonna actually move this up. Because I'm gonna comment this a lot anyway. To kind of know like what I commented. Now I don't need to do any of this. There's no window stuff either, yeah. Not what I meant to do. Or when I actually get this working, we'll clean up all these comments out of it because we don't need these no more. So, okay. Let's actually create the render and stuff. Okay. So I'm gonna go to the ECS. Just coordinator. So how do we start this? Okay, we literally just have an init. So we're gonna go here. And we're gonna do G coordinator dot init. That's actually init function. CS stuff. So let's do G coordinator. Init. Registering components. So I do G coordinator dot register. So I think right now all we have is texture and component. So we'll do and transform. Yes, we're ready to include those. So let's go to the top. That's where our line is. Nah, I should have already lost it. Oh, right here. 9669. So copy that. So we do. I don't think we need to load media. I think that one's. I guess it's about error checking, but it complicates the code a bit. Auto. Now we'll do our vendor system. And it'll be render. Oh, at the top, we're gonna have to do. No, not components. Systems. And then I think we just call init here. Oh wait, I need to like create the signature. So like everything that it has. So I do. So I'm going off the Austin Moreland example right now. And so he goes like this: signature, signature, which was define our ECS. Put on a byte. Texture. Not get component type. And then this also, because we need to set the signature so we can check to make sure that like it has the every entity, what you call it, that has those components are part of the system. So I'm going to transform components. I'll leave a little note for myself and say other. Okay. Okay, now we can also just do render system because we need to initialize it. We can do it right here. Render system, and this returns a pointer. Yeah, so edit. And then he does then we'll go to all entities. Right, just need somewhere to store the entities. So we vector. What did I define? Oh, okay, that's what I was so confused about. I was like, where's the entity class? But I just changed it from, it's just 32-bit unsigned integer. Is this actually an error? I don't think it is. Is it because I don't have no vectors defined up here? Is it? No, it's not. Don't tell me that was the whole time. Wait, is it maybe because... Wait, I think it's because I need to rewrite the alias. I think that might be why. Okay, this made this get annoying. Well, if that gives me an error, I'll deal with it. Oh, I see. We need to create an array of that, so it's initialized all to 0. I think so, right? Because that's the max number of entities. Okay. And then before the main loop, now we set all the stuff. So we need to go. What was that? Bro, are you kidding me? Why is it doing that? Actually, I just want to create one entity, which is the background image at this point. So do I even need this array? No, I don't even need this. So we'll say entity. Coordinator. Okay, here we go. So the component will be we need texture. Oh, and since it's okay. So we do Shit, let me go to the lazy foo. Oh, I scared myself for a second. So the path is going to be source slash. Oh, we should not have done tree. Test background.png. Okay. Okay, wait, I need to open up the image again. Where is docs? It's 1280 by 960 actually. And then that's all, because if we go to my texture component, we have the string path and height. You know what? Setting the entities. Okay, then we need to set its transform. Background, and then it's all default vectors. Okay. Oh, we don't need this, don't need this. Okay, here is where I just do render system. Render system. Update. Maybe undeclared. Oh my God, so much comments. Oh wait, because I did in the init. Which I don't need to do. I can just go like this, all the way back down. Okay, that's good. Then we scroll all the way down here. Don't need that anymore. Before we do that, let's do the render system close. Okay. There's no guarantees, but if this works first try, that'd be pretty sweet. Here comes the errors. Oh, yeah, okay. Oh, we need to add to the CMake first. That's right. Yeah, this file doesn't exist anymore. Let's clear this and tree source. Let's see. We don't need L texture no more. We do need the render system CPP, so we'll do that. Actually, what was it? All right. Oh no, it's capital. All right, please work. It honestly looks pretty promising. Okay, we still have all these errors. I think it's redefinitions. No, previous definition of struct texture component. I think this has to do with the way the header files are set up. So basically we need to make sure that key and redefinitions texture component. System arcs. Yeah, I'm just gonna. Okay, so apparently one way to fix this is just to use the pragma ones at the top of every header pile. So let's go do that. Now that makes more sense why people do this. So basically, I have multiple files including the same stuff. So like you'd include one file, let's say, and that file would include another file, but that other file that file includes, I already included in the one file, the first file. So basically, you get like redefinitions of like a bunch of stuff. And apparently, this pragma once or the if and def stuff. Pragma once is the simpler way of doing it, so that's what we're gonna try. But apparently, if you just do that, then it solves all of your issues. If I delete all those files. Ah, so close. Okay, just this is not bad. This is just some string concatenation for an error message. Wait, what files is it in render CPP? Should be, where is it? Right here. So how do we concatenate? I'm guessing the, let's just see, texture component. No, it's also a string. It's kind of annoying. Okay, I don't know. It's just causing me so much time. I have to load it. Please work. No. Oh my gosh. Okay, wait. I know what's wrong. We don't need it. We're not even using that. Just run with the defaults. Oh my gosh. Okay, let's go. I mean, At least we got the window open at the full size. Okay, now why is it not loading the image? We're gonna try one more thing. If not, we'll call it a night. Figure it out tomorrow. That's right, we don't need that. Okay, so we need to run edit before all these, which we're not. You know, it shouldn't really matter. I guess we can move all this down to there's no way that fixed it, right? Ah, okay, wait out. Shouldn't make a difference, should it? It might. Unable to initialize program. That's why. Be more specific, actually. Okay, I'm gonna try one more thing. If not, that's it for today. So give it the position. Let's give it like 500. 500, like negative 500. These are floats, so I gotta do .f. No, okay, why is that? Must be something with the render. Wait, am I rendering it? No, you always render after you do this. Wait, well, we'll look at that tomorrow. Yeah, that's an annoying bug. But yeah, we'll fix that tomorrow. We'll finally get that working. And hopefully just start with the gameplay. It's the plan. Alright. Thanks anyone for watching.